Okay, today we're going to talk about slope again, but we're going to talk about it, how to find slope in a couple of different ways. So we're still covering the learning standards AA32 and AA33. So the first thing is you might be asked to find the slope of a line that goes through 2 points, and there's two different methods that you can use with this. The algebraic method is just by putting these numbers into the slope form. So if the slope is y2 minus y1 over x2 minus x1, okay, and I usually pick the point where the x-coordinate is the largest, so between 0 and -4, 0 is the largest, and I stack them up vertically, like this, okay, and then I do 5 minus 3 over 0 minus -4, so 5 minus 3 is 2, 0 minus -4 is 0 plus 4, if you use keep change, so that's 2 over 4, or 1/2. Okay, so the slope would be equal to 1/2 in this situation. That's the algebraic method. The geometric method is to graph these 2 points and then look at the line between them and use the line to calculate the slope. So if I graphed 0, 5, it would be right here. Okay, and if I graph -4, 3, so okay, I could do this, and then I can draw the line in between them. And this hypotenuse is not really of concern for me. What I'm looking at is the change in y, okay, versus the change in x. All right, so the x went positive, so the x changed from this point to this point in a positive direction, so it went 1, 2, 3, 4. Okay, so it went over to the right 4, and then the y changed in a positive direction too because it went up 2. Okay, so the ratio of rise over run is 2 to 4, which is 1/2. Okay, so there's two ways you can do it: geometric and algebraic. Now, if you were given a line and asked to find the slope of the line, you can, again, there's two different methods. You can use the geometric method, which is finding any 2 points on the line that are convenient. So this one's pretty convenient because it goes through, I can see the x and y values are both integers here. So I can use that point, I can use this point right here. Now, let's try this. So from this point to that point, it went down 1, 2, 3. So I'm going to put -3, right? Because if it goes down, you want to represent that as a negative. And then it went to the right 2, okay? So your rise over your run is -3 over 2. And that doesn't reduce any more because 3 and 2 don't share a common factor, so you want to just write the slope is equal to -3 over 2. Okay, that's one way of finding a slope. Another way of finding a slope is by you can pick off the coordinates of the points that you just found. So find two coordinates whose x and y, or find 2 points whose x and y coordinates are integer values. Here, this coordinate looked like it was 0, 5, and this coordinate looks like it was 2, 2. Okay, so let's write these points over here: 0, 5, and 2, 2. Let's actually write them so the 2, 2's above the 0, 5, and then I can sort of just go downward, and so I do 2 minus 5 over 2 minus 0. Okay, so that's -3 over 2, which is the same as -3 over 2. So two different ways: algebraic and geometric. And by the way, even if you had kept the points stacked on top of each other like this, you would still get the same thing. You get 5 minus 3 over 0 minus 2, so that is still the negative, that's 5 minus 2. Okay, that's 5 minus 2 over 0 minus 2. So 5 minus 2 is 3 over, and then 0 minus 2 is -2. Now remember that 3 over -2 is the same thing as -3 over 2. Okay, so either you have the negative sign in the denominator or you have it in the numerator. You just can't have it in both, okay? Negative 3 over negative 2 is not equivalent to negative 3 over 2. These are not equal. But the negative 3 over negative 2 is the same thing as 3 over 2. So actually, if you had two negatives in the numerator and denominator, you could factor out a negative 1 and then cancel it. So, for instance, you can factor out, let's show you just algebraically what this means. So, with negative 3 over negative 2, I could rewrite that as negative 1 times 3 over negative 1 times 2. Essentially, it's drawing the negative sign out of the integer 3 and 2. And then since negative 1 and negative 1 are the same, I can cancel that number from the numerator and denominator, and that gets 3 over 2. Okay, that is why negative 3 over negative 2 is the same as 3 over negative 2. I'm sorry, as 3 over 2. Okay, now let's say you were asked to draw a line through a point with a slope, with a given slope. So draw the line through the point 3, 4. So first let's plot that. 3, 4 is right here. And a slope of negative 1 over 2. So remember, this is rise over run. So this means that we have to go down 1 and right 2. The fact that it's negative 1, that means and it's negative. It's the remember, the numerator here is the change vertically. Okay, and the denominator is the change horizontally. So if the numerator is negative, it means to go down, and right 2 means that it's positive 2 in the denominator means you have to go right 2. So from this point 3, 4, we go down 1 right here, and then right 2. So this is another point on the line. Okay. Now we can do that again. We can get another point by going down 1 and right 2. Okay. Now you might remember the claim from the last slide that negative 1/2 was the same as doing 1 over negative 2, and that's still correct. This is the same. Going 1 over negative 2 is the same as going up 1 and left 2. So let's see what happens when we do that. If we go up 1 from the original point, up 1 and left 2, we'll get this point right here. And you'll see, if I do that, I'm going to get a point to the left of the original point. But that's okay because all 4 of these points are collinear. So if I did it one more time, I'd get this point, right? If I did it one more time, I'd get up 1 over 2, I'd get this point. All these points make up the same line. Okay? So if I say that you have a slope of negative 1/2, you can either choose to do that. You can go down 1, right 2, or you can go up 1, left 2. Okay? Now let's try it one more time. Draw a line through 1, 2 with a slope of 2. So 1, 2, let's plot the point first. There's 1, 2. Now, the slope is 2, and that's not super helpful for us because we want a ratio, rise over run. And so we have the numerator, but we don't have the denominator. But remember that 2 is just 2 over 1. Okay, so it means we want to rise, and this is positive, so we want to go up 2, and this is also positive, so we go right 1. So up 2, right 1 gets us this point, up 2, right 1 gets us another point. If I keep doing that, I'm going to continue to get points on the line. Or remember that 2 over 1 is the same as down 2 and left 1. Right? So if I took from my original point, I went down 2 and left 1, I'm just going to get a point that's left of the original point, but still collinear. Right? All these points are collinear. So here is my line. Okay? All right, let's try it one more time. Draw a line through the point 0, 1 with a slope of negative 6. Okay, so I want to do negative 6 over 1. Remember that means down 6 and right 1. Remember that's also equivalent to doing 6 over negative 1, which is up 6, and left 1. Okay, so that's 0, 1 is right here. And if I go down 6, 1, 2, 3, 4, 5, 6, and right 1, I get this point. But if I went up 6, 1, 2, 3, 4, 5, 6, and left 1, I'd get this point. Okay? So all these points are collinear. and your line is this really steep line right here, okay? And I have not been putting the equation on my line. We're going to learn how to determine the equation, and actually it looks like this equation is y equals negative 6x plus positive 1, and I can get that negative 6 from that slope. We're going to learn how to do this next, and this positive 1 comes from the y-intercept, which is right there. Okay, so our next step is like looking at an equation, looking at the graph of an equation and finding the equation for it. Okay, all right, so that's the end of the lesson today.